That's the joke, at least. Oh, it's done? Cool. So, hello. As Kim wonderfully mentioned, I'm Nathan. I'm a student here at OSU's Cascades, and I am part of Hacker Refactor. Welcome to Spring Quarter. We didn't have a speaker lined up this week, so I thought it would be a good time to talk a little bit about dev environments, since you'll be setting stuff up for your classes. And I thought it would be a good time to try and convince you to join my religion, which is GitHub Codespaces. I use it all the time. And so just give you a sense of the structure of this presentation, I'm going to briefly go over what a development environment is and talk a little bit about the different ways you can set up your development environments as a student. After that, I'm going to introduce GitHub Codespaces and walk you through how I'm using it for my classes this quarter. So, what is a development environment? The definition changes depending on the context and who you ask, but for our purposes, a development environment is all of the tools you use to write, build, and test a program. So this is like your text editor, vscode, Vim, etc. Vim's for you. The terminal, software that you need to make the code run, the Python interpreter dependencies, things like that. Any debugging tools you're using, version control, super important. If you're new and you feel kind of meh about version control, figure it out. It's very good. It's going to help you in a lot of different ways, and I'll show you a really easy way to set it up today. And all of that's running on top of your operating system and whatever hardware your dev environment is running on. Most commonly, this is what I'm going to call a native development environment. This is the kind of environment you're probably most familiar with when you're in a Software 101 class. You know, the teacher's going to have you download Python onto your computer like any other application, download PyCharm, and you're going to walk through like learning how to program in that kind of a way. That is a native development environment. It's really easy to set up, but as you go from class to class, that environment is going to get messy, right? You're going to move from Python, you're going to go over to Ruby, you're going to maybe have a different Ruby project with weird and annoying dependencies. Maybe you'll be using C, maybe you'll be using Java, right? All of these different things will start to clutter your dev environment and possibly cause conflicts. So like it kind of gets pretty fragile over time. You'll probably run into a situation where instead of working on your assignment, you're working on fixing your dev environment that broke because you updated some package or something. It's kind of annoying. It's also very difficult to move from one machine to another. If you're working on your laptop at school and you want to work on your project at home on your desktop, you have to set up two different environments and hope that they are the same and that your code will run on both of them. So while easy to set up, it comes with a lot of complications. And so that leads us to containerized development environments. So before I can talk about GitHub Codespaces, I do need to talk about Docker containers. You don't need to know about Docker containers to use Codespaces, but understanding it a little bit is important if you want to understand how Codespaces work. So let's talk a little bit about containerized development environments. It's okay if your eyes glaze over on this slide. Just promise you come back to me during the demo. Unlike in a native development environment, in a containerized development environment, your tools and software are not installed directly on your machine. Instead, it all lives in a container. And you can think of a container like a little box. You put all your code, tools, and dependencies into, and all your code runs inside this box. When you hear people talk about Docker, these containers are what they're talking about. The first time you'll probably run into Docker is Software Engineering 2, and that class is a great example of the utility of containers. In that class, you're working on testing a legacy Ruby on Rails application. The application is old, It's horrifying, and it needs a bunch of outdated dependencies to get it to work. In the past, just getting the application running was a huge struggle for students, but last quarter, Beej, he changed the course structure, and now students are given a Docker file that includes all of the old dependencies that the project needs to run, and you can just use that Docker file to build a container that the application runs in with no problems. It's made starting up in that class a lot easier. So today, I'm not going to talk about how to set up and run a containerized environment. It's a little bit outside of the scope of my presentation. But if you're interested in doing containerized development environments on your machine, I highly recommend checking out a VS Code extension called Dev Containers. It makes making containers for projects much, much, much easier. All you need is the extension and Docker installed, and you can follow some guides online. It's very interesting. So with that out of the way, I can finally talk about GitHub Codespaces. GitHub Codespaces is what I'm going to call, I don't know if this is a real term, but a containerized cloud development environment. So instead of coding on your personal computer, you instead program on a computer in the sky. At its core, Codespaces is just pre-configured, customizable Docker containers running on a server somewhere, deeply integrated with GitHub and VS Code. Microsoft has put a lot of work into making this as easy as possible and making it feel as native as possible. So it's really interesting, and I'm excited to show you some examples of how you can use it. Some of the benefits of working in a cloud environment instead of locally is it's completely independent from your local hardware. So when you're working locally on your machine, if you're running on a 2018 Acer mid-range crap top, right? You're going to run into a lot of challenges really quickly, like trying to get things to run quickly and to work well. And when you're working on a different computer, your computer doesn't have to do any of that legwork, which is really awesome. It's also really cool because it's accessible anywhere. Like if you're dealing with working on the laptop, working on a desktop situation, you can just open Codespaces on either one. It'll be exactly the same. You're not going to notice a difference. Another really valuable thing is that it's integrated with GitHub. So setting up version control is, I think it's 2 clicks. It's pretty cool. It's pretty awesome. And it is basically free. I'll get into that asterisk at the end of the presentation. But if you have GitHub Pro, which you can get through the student developer pack, you just sign up with your school email, show them your ID. It basically makes GitHub Codespaces free for you. Some of the cons with containerized development environments: it's not going to be compatible with every workflow. I'll talk a little bit about that later. And you need access to the internet, so it's not going to work on a plane. So let's go ahead and move on to the demo, which I have not actually run through. So this might be a little bit janky. But I figured that I'm going to show you how I would set up Codespaces for 2 of my assignments that I'm doing for school right now. So the first one, let me just move this over. Blah, blah, blah. So smooth. Is analysis of algorithms, right? So for our first assignment, we're going through a Jupyter notebook to implement some algorithms and analyze their time complexity. So the instructions say to download it, add it to a Colab. We're not going to do that. We're going to use GitHub Codespaces. So let's go ahead and download that real quick and go over to github.com. So this is the GitHub dashboard. This is my GitHub homepage. Very exciting. And if you go over here to the hamburger menu and look down here, there's the Codespaces button. This is how you get to GitHub Codespaces. And you can kind of take a look here and see what this page looks like. It has all of these templates on things that you can just click and create a GitHub Codespace for. It can be blank. You can make one for React, Ruby on Rails, Jupyter, things like that. And all of your existing code spaces that you have are going to be down here. The one thing I want to point out, because I'm going to forget later, is GitHub will delete a code space if you don't use it for a couple weeks. So if you want to have a code space for a really long time, you just click on here and you make sure that it's bookmarked. So let's go ahead and open up this IPNYB file. So we're going to go ahead and create a new Jupyter Notebook code space. That is not the button I should have used. I should have clicked that button. So it's going to go ahead and create a code space for Jupyter Notebooks. And hopefully it will do it pretty fast. There it is. Pretty cool. Let's go ahead and close the terminal because we don't need it for this part of the demo. But you can kind of see it just opened up an instance of the web version of VS Code. The web version of VS Code is almost completely feature parable? Don't know. With the native VS Code interface. So you can see that you have all of your extensions. This particular code space is pre-built by Microsoft using this devcontainer.json file. If you're familiar with Docker, this is going to look very familiar. This is the Docker file that we were just talking about earlier. So you can build code spaces exactly the same way that you build Docker containers, which is pretty cool. But Microsoft does it all for you, so you don't even need to think about that right now. This particular instance has a bunch of example data. So you can see all these different IPNYB files that are already built in. Because we're doing a homework assignment, let's go ahead and throw those in the trash. Yeah. So let me go ahead and grab that lab assignment file, and we're going to try and move it over here. And there you go. It is, actually that just opened it. It didn't put it into the wrong place. Very sad. Where's my mouse? There's my mouse. Doop-a-doo, up, side, there you go. Now it's going to upload it into the Docker container. You'll see it right here. And you can go ahead and just run it. Select the Python environment that's already installed, and it's just going to go for you. You see that it's already set up with everything that you need. And another really cool thing, you can just go ahead and init, whatever. You can commit this. Let's go ahead and stage all the changes because I forgot to press this button. But there we go. We made our first commit. Very easy. And we can just click Publish Branch. And because we're already in GitHub's world, it doesn't need to authenticate us at all. It already knows who we are. It already knows our GitHub username. And we can just publish this to a public or a private repository. Let's go ahead. What's a good name for this? Delete me, please. And we're going to make this a private repository because it is a homework assignment. We don't want any academic integrity issues. So that's it. That just published the source information over to our GitHub. So let's go ahead and take a look at that. How do you look at your repositories and never do it? Here we go. So now we see we have delete me, please. We go into it, and we can see that we have all of our information. We can just commit to it like we would normally on any other repository. An interesting thing that's included here is this .dev container file. So if you delete this code space and you want to work on it again, you can just click down here and it will allow you to generate a new code space using that configuration, and all of that will be there again. One thing I do want to say, that this operates just like your VS Code instance if you're working on it natively, right? You make changes to a file, you save it, you don't commit it. If you close this and reopen it, that file will be exactly the same as it was before. So you can treat it like it's persistent. You can trust that your data is going to stay there, and you can use it just like a local dev environment. So that's, I think, everything that I wanted to cover with that example. My second example is a little bit more fun, I think. Let me go ahead and pull up programming language fundamentals. Let's go ahead and take, yes? Hi.
What happens if I pull that? Because now it's a remote repo
Mm-hmm.
on GitHub, and I just get cloned into my hard drive.
You can just do that. It's like a normal repository. If you push changes up to it, you can sync those changes like it's a different machine on the GitHub Codespace instance.
So the container stays in the cloud.
Yes.
It doesn't end up on my hard drive, or it does, and then it doesn't affect
So
my dev.
anything that's in the container that's not pushed to the repository, if you pull the repository down, it's not going to have that temporary information. You can open Codespaces on your native VS Code instance. There's like a little button, it just says open it in native, and it pulls it up and it looks exactly the same. It's still running remotely. You can kind of think of it the same way VS Code would connect to a WSL or like SSHing into another computer. It interacts with Codespaces in the same way. No worries. Let me know if you have any other questions. So let's pull up the Raku lab, which is pretty cool. I think. I don't know. I haven't done my assignment yet. I was working on this presentation. But for the first assignment in programming language fundamentals, we need to play around with this imperative programming language called Raku. I don't know how to use it, but we're going to play with it today. So the instructions for doing this lab is you download Raku, and you download this set of files, and you work on it. So I'm going to go ahead and move that away because I need to follow it while we are creating our space. So let's go ahead and start with a blank code space. This is just like the default code space environment that Microsoft releases. And we're going to go ahead and set up code spaces to work with Raku. Let's go ahead and just say that, yeah, whatever. I don't care about you. So here we are. We have a blank VS Code instance. This is running Ubuntu. So if we go ahead and do sudo apt update, you can see this is actually just an Ubuntu operating system running in the sky, and it's great. So let's go ahead and see what we need to do to install Raku. It says we go over to rakuduo.org, and we can see here that there is a, I don't want to do that. I want to go over here. And let's see. Let's click download. And how do we install it? I actually already know how to install it. I'm kind of just pretending. But yeah, so like if we're running on Ubuntu, we can just apt-get install Rakuduo. So let's go ahead and paste that in. Yeah. Cannot open the log file. Oh, I didn't do sudo. Sudo. Yeah, paste it. Do not ask me this anymore. So let's go ahead and say yes. What? I say yes. Yes? There we go. Okay. I don't know why it thought I said no, but I said yes, and it's installing it. While it's doing that, let's go ahead and take a look at our extensions and search Raku. And we can see that there's a Raku extension, as there is on all regular VS Code. So there we go. We have the Raku extension. It's installed. Let's go ahead and just move that starter pack that we got over for the assignment. Doop-a-doo. Doing that thing where I have to drag stuff over, go up to this display, right to this display, copy it over. Awesome. So there we go. We have ourselves a starter pack. We can click on this. We can see all the code, all highlighted like a normal thing for Raku, I assume. I don't know how to use it. But let's go ahead and show that this works, and you can follow the instructions in the thing. So it says begin by running the program. So let's do rakudo lab1.raku. Spelled it right? Yeah. Could not open. ls. Okay. CD 381 labs artifact. There we go. No. Yeah? No, is that what it's called? Okay. CD. There we go. I love you guys. And we're just gonna, it's not lab 1, it's lab 1 template.raku. Okay. There we go. Yeah, there it is. Okay, so here's the first command. Let's just copy and paste that. Copy, paste. And there you go. This is what's supposed to happen during the lab. Raku looks terrible, I hate it. But there you go. Like, this is a pretty weird, unusual language, I would say. I'm never going to touch this again. As soon as this class is over, I'm going to delete this code space and clean it from my life. But it will still be in my GitHub repositories. Because let's go ahead and I'm actually going to keep this one, so we'll call it Raku. And where'd my mouse go? Crazy. Okay. Private repository. Yeah. I really should have just. There we go. And we can kind of go over there and see that we have our stuff. Now, because this code space is blank, like you can kind of think of it as like just like a blank Ubuntu server. There's no pre-configuration happening with code spaces. It doesn't have that .dev container, dev environment folder. But we could add one there if we wanted to set up like installing Raku and installing the extension. That's something that you could figure out how to do. I don't know how to do it. But it doesn't matter because that is the end of my demo. So let's go ahead and go back to our presentation and make sure that I have covered everything that I want to cover here. I have a little bit of notes. Yeah, just generally, like the process I would recommend for using GitHub Codespaces is like at the beginning of the quarter, create a code space for every single class that you're in that you want to use Codespaces for. This is really useful because like you can kind of just think of it as like your class box that you do everything in. Like if you have to do assignments and you want to submit them to Beej and Markdown, you can just create Markdown files in there. You can install all the different things that you need to get that class to work, get all of their dependencies and stuff. And then like when you're done with the quarter, you can have all of the stuff that you worked on in a repository that you can reference for the rest of your life if you need to. It's a really interesting, good way to kind of structure your progress through a course. And now I want to talk a little bit about when not to use Codespaces, because it does not work for everything. Specifically, Codespaces is bad for projects that require emulation. It doesn't have emulation capability. It's bad with working with old versions of Ruby. I'll talk about that in a second. Projects that use a lot of space or anything that requires a GPU. The instances of Codespaces, you could choose between a 2-core 8 gigabyte machine and a 4-core 16 gigabyte machine. There's other options for corporate customers, but we're not corporate, so it doesn't matter. So with mobile software development, don't use Codespaces because you can't do emulation. So if you're working on a Flutter project and you're targeting web, it works fantastically, right? Port forwarding, set up automatically. You can display, you can do live editing of your stuff, just like if you're like working on Flutter locally. It's very good. But if you're trying to target an iOS or Android device, that is not currently set up. The second class that I recommend not using Codespaces for is software engineering 2. You might think it has a Docker file. You can just use that Docker file to make a container, and you absolutely can. It'll work. You just put it in there. It'll figure it out. But the problem is in software engineering 2, you're using an ancient version of Ruby 5. And when you're trying to open up the dev server of the website, it's actually a super fun problem. Ruby has a security feature where if you're trying to open up the dev server on anything other than localhost, it's gonna freak out. And GitHub, when they do their weird port forwarding thing, instead of going to a localhost, it goes to the URL of the GitHub Codespace with some stuff. So it doesn't match exactly what it's working for. I actually was able to do it in Codespaces because my husband has a master's degree in software engineering and he's a senior software engineer, and he spent an hour figuring out how to disable the security feature. I don't recommend it. It stopped my progress in that class for a week. But other than that, Codespaces is fantastic. I haven't run into any other issues using it with any other classes. So let's take a look. Let me make sure. Yeah, that's it. So let's take a look at what I mean by it's free. Okay, so by default, they count the cost through core hours. So it's a little bit complicated. But basically, they give everyone 60 hours of the lower tier instance for free and 15 gigabytes of storage. With GitHub Pro, that goes up to 90 hours with 20 gigabytes of storage. That equates to 3 hours a day. Now, this only counts when you're actively working on your stuff. So you can have it open. If you're inactive for 15 minutes, they'll automatically pause your code space. So it's not just gonna tick up forever. I have never gone over this limit so far. I have gotten close to the storage limit, which is why I mentioned if it uses a lot of storage stuff, maybe avoid that. But it's effectively free in the sense that I've never gone over the limit that they give me. And the cost when you go above it is very reasonable. 18 cents an hour is pretty much nothing, I would suggest. After 90 hours, I would have a hard time imagining going over that. Storage is equally reasonable, 7 cents a month for what it provides. I think that's pretty good. That's all I've got. You're welcome. Happy to take any questions. And I forgot to press this button, so it has just been looking at my face the whole time. Awesome.
So hard to remember to press that thing.
I understand now, Beach.
Can you export that configure that Docker file? If you're in Codespaces and it auto-creates it for you, and then I'm
You can just download anything from it. You can just right-click and download it. It downloads like it's a normal thing.
So for the Codespaces, you sudo apt installed in the terminal there.
Yeah.
I'm assuming when the Codespace gets deleted, it just also deletes that, right? And you have to probably sudo apt install Raku?
Yeah, if you deleted the Codespace, you would need to reinstall it. I would recommend just not deleting the Codespace. If we go, I don't know if I made this super duper clear. Let me just go back over to my Codespaces, move that back over here. So if you go over here and you look down here, we still have all of the stuff. So we weren't using, we closed out it's setting up the Codespace. And it's like you put your computer to sleep. and you're opening it back up. Raku is still here. All the stuff is still here. It still has all of it's exactly the way that I left it. Does that make sense?
Yeah.
So if I wanted to keep this forever, which I do not, I would go here and I would click this button to uncheck the auto delete code space button. And this is not going to be a surprise to you when this happens. It's going to send you an email when you go and you look at your code spaces. It'll tell you that it's expiring, if it's expiring soon. This one's expiring in 4 days. This is the code space that I used to do my software engineering 2 final. So the expiration is quite long, several weeks.
Yeah, so you said that each code space is essentially its own individual computer.
Yes.
So anytime you have to like download dependencies or anything like that, you'd have to do it for each individual code space, or if you like when you download Raku, would that also impact all the other code spaces you have?
Every code space is like a separate computer. If you wanted to make it so that when you set up a new code space, it had the stuff, you would create a Docker file that had those things listed in it. Yeah, does that answer your question? Okay. Awesome. Okay, well, it looks like we're done. Thank you. Okay, you?
Yeah, do you download anything on your computer anymore, or do you just use code spaces for everything?
I still use my native VS Code and native dev environment pretty much exclusively for Flutter because I need that emulation. I tried to set it up through Docker to like push all of that into a nice clean space and not have to do anything locally, but it did not work. So for things that my general perspective is, if you are working with hardware, like you're doing microcontrollers, you're doing, pushing to a phone that you have on your desk, or you're trying to do any sort of like stuff like that, you need to do it natively. If you're working with the GPU and that's it, like you're trying to do AI stuff, live in a dev container. It's fine. But anything that requires you to like configure like access to your USB port or things like that, it's just more work than I think it's worth.
Does it warn you before it charges you, or is it like AWS?
Yeah, they have spending limits that you can set up. I can kind of just
Yeah, Professor Donnelly to do.
So by default, spending limit is 0. So it's not going to charge you at all if you go over. It's just going to stop access. And you can configure how much you're willing to set up for that. If you want to learn more about all the different things, I only covered a corner of like how to interact with GitHub Codespaces. You can create a GitHub Codespace from any repository that exists on GitHub, which is pretty cool. What other ways can you? I already mentioned the Docker file thing 3 times. That's actually most of the ways. But it integrates with the JetBrains IDE as well. So if you prefer to work in that ecosystem, you can still use Codespaces if you want it.
Is there a limit to how many code spaces you can open?
At the same time?
Like, how many can you have on your account?
So I believe the limitation for how many GitHub Codespaces that you can have is the storage limit, right? Because you're given 20 gigabytes of storage, and like the amount of space that each code space takes up is, some amount greater than 0. That is how it. I'm just going to search for it because I'm making things up, and I should just ask how many code spaces can I has? That is not how you spell anything. 1 per repository. Seymour. Yeah, so it looks like it's just limited by the limits. It doesn't have any additional limits.
What this all makes me think of is this cycle that seems to happen in computing between thin clients and
Yeah, the mainframe thin client.
So the more powerful computers at some points in time are off-site computers, and so then you have some little lightweight front end that goes and accesses those computers. And then after a while, sometimes these computers get more powerful, and then those ones in the cloud or the mainframes, they go away, and then they get more powerful.
Yeah.
Interesting cycle.
It definitely feels like we're moving back to the mainframe, right? Like we've got all the compute that they're throwing into large language models that only works with giant computers, right? We've got like basically all of cloud is moving back to the mainframe. So
Just like CPU time accounting, like something that happened back in the 70s. Mainframe was like used 4 cents of CPU time, so there we go. It's doing that kind of stuff again. I kind of like it.
This is super cool.
yeah, I think so.
So appreciate you.
Of course. Thank you guys for coming. Yeah.
Version control, is it very similar to just how you would do it in your terminal commands, or?
It is exactly the same as you would do it in VS Code, but you don't have to set it up. It's just set up for you. So you can just start it, and you don't even have to have a repository. You can it'll just create one for you.
Did he play Doom in it?
Okay, can you play Doom?
Can you play Doom in GitHub Codespaces?
There's probably an extension for it.
I bet you could.
Someone's figured this out.
Yeah. If you can play Doom in a web browser, you can just create a version of that website in GitHub Codespaces and launch it. And it'll port forward it over to the tab, and it'll work. I've never done it. I don't know how to do that. But I feel confident that it would work.
Hopefully you can open it in all of your code spaces.
I just love asking questions.
I love it too.
So, I know that some issues that you have whenever you sudo apt install is element or path element variables. Do you ever have to modify those within a Docker container or like within this code space? Is it pretty intuitive or just automatically rectified?
So I haven't had to mess with the path in GitHub Codespaces for anything that I've installed through the usual package libraries. If you're installing something from like a tar.gz file or whatever, you probably will still need to add it to the path like you would in a regular Linux machine. It doesn't have outside of like setting it up, integrating it with the browser, integrating it with VS Code, like it doesn't change things on you after it's running, if that makes sense. It's just Ubuntu in the sky. Awesome.